Hey there, folks. Welcome back to the channel. Today, we're diving deep into the world of data science, focusing on a key topic: classification. I've got an exciting lineup for you as we discuss the top 6 machine learning algorithms tailored for classification problems. We're talking logistic regression, decision tree, random forest, support vector machine, k-nearest neighbor, and naive Bayes. I'll break down the theory behind each and show you how to implement them using Python. Whether you're a seasoned pro or just starting out, this video is your gateway to mastering these algorithms. So, without further ado, let's jump into the world of machine learning and level up our coding game. Now start with logistic regression. Logistics regression uses sigmoid function above to return the probability of a label. It is widely used when the classification problem is binary true or false, win or lose, positive or negative. The sigmoid function generates a probability output. By comparing the probability with a predefined threshold, the object is assigned to a label accordingly. Below is the code snippet for a default logistic regression and the common hyperparameters to experiment on, see which combinations bring the best result. Decision tree. Decision tree builds tree branches in a hierarchy approach, and each branch can be considered as an if-else statement. The branches develop by partitioning the dataset into subsets based on most important features. Final classification happens at the leaves of the decision tree. Decision tree common hyperparameters. Criterion, max depth, min samples split, min samples leaf, max features, random forest. As the name suggests, random forest is a collection of decision trees. It is a common type of ensemble methods which aggregate results from multiple predictors. Random forest additionally utilizes bagging technique that allows each tree trained on a random sampling of original dataset and takes the majority vote from trees. Compared to decision tree, it is better generalization but less interpretable because of more layers added to the model. Random forest common hyperparameters: n estimators, max features, max depth, min samples split, min samples leaf, bootstrap. Support vector machine, SVM. Support vector machine finds the best way to classify the data based on the position in relation to a border between positive class and negative class. This border is known as the hyperplane, which maximizes the distance between data points from different classes. Similar to decision tree and random forest, support vector machine can be used in both classification and regression. SVC support vector classifier is for classification problems. Support vector machine common hyperparameters: C, kernel, gamma. K-nearest neighbors, KNN, is a simple yet effective algorithm for classification and regression. It calculates the distance between a new data point and existing ones, identifies the K-nearest neighbor, and makes predictions based on majority voting, classification, or averaging, regression. Despite its simplicity, KNN's performance is influenced by the choice of distance metric and the value of K. KNN common hyperparameters: n neighbors, weights, leaf size, peep, native Bayes. Naive Bayes is based on Bayes' theorem, an approach to calculate conditional probability based on prior knowledge, and the naive assumption that each feature is independent to each other. The biggest advantage of naive Bayes is that, while most machine learning algorithms rely on large amount of training data, it performs relatively well, even when the training data size is small. Gaussian naive Bayes is a type of naive Bayes classifier that follows the normal distribution. Gaussian naive Bayes common hyperparameters: priors, var smoothing. Stay tuned for more exciting content, and until next time, keep learning, keep growing, and keep innovating. Thank you for joining us.